Welcome to the demo for Lesson 1, College Algebra. We're going to do these problems from the prerequisites chapter as a brief review. So remember for part A here, when you raise a power, when your power is a fraction, then the number on the top is a power and the number on the bottom of the fraction is actually a root. So this is all of this raised to the first power and cube rooted. So I'm going to rewrite this as the cube root of 64, x to the 300, y to the 600. And then I'm going to take the cube root of each of those things. When they're separated by multiplication, you can cube root each one. So the cube root of 64, that would be a number that you multiply it times itself 3 times, and you get 64, and that would be 4. 4 times 4 is 16, times 4 is 64. Okay, and then I need x to a power that when I cube it, I'd get 300. So x to the something, so that when I cube it, I'd get 300. And remember, when you raise a power to a power, you multiply exponents. So what times 3 would give you 300? 100. And then the cube root of y to the 600 would be y to the 200. Okay, for B, we have 8 to the negative 2/3. So now I'm dealing with a crying baby, right? A negative exponent and a fractional exponent. So I'm going to use 2 rules that we've gone over here. I'm going to put that crying baby down for a nap, move it into the denominator. So it's going to become 8 to the 2/3 positive. And what's left in the numerator is just a 1. And then the 8 to the 2/3, I'm going to do that as a power and a root. The 2 is the power, the 3 is the root, because roots belong in the cellar, like a root cellar. So this is 1 over the cube root of 8 squared. And the cube root of 8 is 2, so this is 1 over 2 squared, or 1/4. Okay, part C, we're going to revisit factoring. 5x cubed minus 45x. So both terms we can factor out a 5. 5 is a factor of 5 and of 45. And I can also pull out an x. And then I'm going to treat this like a sort of a reverse distribution problem. What do I multiply 5x by? So 5x times what would give me the 5x cubed? And that would be x squared. And then I would say, okay, 5x times what would give me negative 45x, and that would be negative 9. And it's tempting to move on, but if you have some experience with factoring, we should recognize that x squared minus 9 is a difference of perfect squares, and that can be further factored. So this is going to be 5x times x plus 3, x minus 3. And then finally, I want to add these 2 fractions, 3x over x plus 2 plus x over x minus 2. And we all remember that to add 2 fractions, you need a common denominator. So I'm going to write this as 3x over x plus 2 plus x over x minus 2. And then I'm going to get a common denominator by multiplying each fraction by a fancy form of 1. Okay, so this one over here I'm going to multiply by x plus 2 over x plus 2. So when you put something over itself in a fraction, that's really just a 1. We call it a fancy form of 1. So we're multiplying this fraction by 1. We're not changing its value, we're just giving it a different denominator. And then same thing over here, but this one I'm going to multiply by x minus 2 over x minus 2. And now both fractions will have the same denominator, x minus 2 times x plus 2. So I have, when you multiply fractions, you multiply the tops and you multiply the bottoms. So on the top, I have 3x squared minus 2x. Just distributed that 3x to my x minus 2. And on the bottom, I have x minus 2 times x plus 2. And then my second fraction is going to be x squared plus 2x over x minus 2 times x plus 2. And once you have a common denominator, you just add the numerators when you're adding fractions. So I'm just going to combine like terms in the numerator. And I have 3x squared plus x squared, which is 4x squared. And minus 2x plus 2x, which is, oh, I made a mistake. Oops. Okay. Back here, this should be 3x squared minus 6x. Let's fix that. So 3x squared minus 6x. And this one is still x squared plus 2x. And now I combine like terms and I have 4x squared minus 4x over x minus 2, x plus 2. And then you could factor this numerator if you want. It factors to 4 times, oh, actually I can pull out a 4x. 4x times x minus 1 over x minus 2, x plus 2. This answer also would have been acceptable. There's no reason that you need to have the numerator and denominator factored. Another acceptable answer would be if you had multiplied these two factors in the denominator together.